Hi, I'm Mike. Welcome to the, I don't want to say the shop, because this time we're in the garage. So this is a 1979 Yamaha XS650. And I am building it to the way I want it. The previous owner had cut a bunch of stuff out, but what today's project, if this works, and if it does, it'll be cool. If not, well, it should be entertaining. Anyway, I bought the suspension from a Suzuki DRZ400, which I've shown a tiny bit of in the other ones, just making little bits and pieces. Anyway, the space in here, there's two things we got to do. It is a little bit too narrow, not a lot, but some. It won't fit in there, but there's, and I know you can't hardly see this, but there's about 6 millimeters of extra steel past the weld that stick in. So we've actually got enough room to trim these without affecting the structural integrity, which is great. The second thing is that the bores are 16 millimeters and the pivot bolt for the Suzuki suspension is 17, which I have to really maintain because it's got needle roller bearings that run on that shaft, and they're 17 millimeters. I could try to get something else, but since I've got it, boring this part out is easier, I think, than this. So we've got a few challenges. Let me show you what we've got. So there's a few ways to approach this, and the easiest way is to just come in here with an angle grinder and grind on these till I can get them to where it fits. But I really want it to be square, really square, which, you know, with an angle grinder file you could get there, but I'd rather do this on the mill. And I was originally hoping, I wanted to do this on the mill, but there's just no good way. I thought maybe I could lay it on its side, clamp the bottom to an angle plate, but the biggest, there goes the heater. The biggest angle plate I have is not big enough. So that was out. So we're going to try to do it just sitting here. It's tied down to the lift, so it's not going anywhere. So what I've got a couple things. Let's make sure this will show up on the camera. Okay, I know this the lighting in here, and it is what it is. Anyway, this is a spot face cutter, and it's actually left-handed. It cuts counterclockwise, which is fine. So I made a video the other day. I showed making a test piece out of aluminum that was the driver for this, and this one fits. Once I got it in there, I'm not going to get it out. I could get it out, but I don't need to. So anyway, and I know you probably really have to see, but there's two flats in here that are left over. This fits into the recess on here, so it's actually very positive. Then I made a shaft with matching flats on it, and then it's all got a pin to hold it to keep it, to transmit torque, plus the flats. And then we've also got, in the end of this is a pilot. That's the right direction. Got a pilot that goes in here. So this is 16 millimeters. This pilot, this spot facer, it's got a 5/8 thing, which is only about 4 or 5 thousandths of difference than 16 millimeters. So I just turned that just a hair. So one thing that concerned me is because I have to run this backwards, is that the screw would back out. So I actually calculated and drilled in so that the pin goes through the screw. So once this is screwed together and I put the pin in there, this bolt can't back out. Because I thought about getting a left-handed bolt and a left-handed tap, but for doing one thing with two of these, or two flats, the price was just way excessive. So anyway, this, I haven't even tried this yet, so this should fit here. Okay, so that's good. That fits good. 16 millimeter. That's right. So anyway, that's the first half. Assuming the spot face works, The second half of what we've got to do is we've got, and I just realized there's a problem with this. I'm going to do kind of a line bore thing. So I've got another piece of 16mm drill rod. I've put a square hole in there, which I did with a file. I made a little cutter, which is right now sticking out just about a 1/2 millimeter. So if this goes in, actually it'll be okay. It'll go in and bore this to 17mm. At least that's the theory. It should work. I did do a test piece. I actually put a thing in the lathe chuck, mounted this in the carriage, and bored it, and I got like 17.1. So that, and it doesn't have to be super good, but that's pretty close as good. But once it goes through one side, it'll be loose. So I've made a few spacers just out of some aluminum. They are 16mm ID, 17mm OD. I've verified they will fit into the Suzuki suspension, so I know they're the right size. So if the spot face goes right, then we're going to go through here with this cutter, bore through the one side, and it'll go in, put our sleeves on, and bore through the other side. Now ideally, I would do that side first, but then I got to take this cutter out and get it back to the right size. Maybe I'll do that. I don't know. It wasn't bad to do this on the surface plate with a dial indicator. Kind of difficult otherwise. So the last thing we got to do is measure this. Okay, I've got a 12-inch dial caliper, but because of the way the frame is, I can't get it in there. And I want it accurate. I want, 5mm off each side or whatever it's got to be. So what I'm going to do is do a transfer method, like you would do with gauge blocks, kind of. So I've got a couple of big pieces of, I don't know, like, it's like 1/2 inch by 1 inch high-speed steel tool blanks. So what I'm going to do is I'm going to clamp them to the inside face, and then I can measure across them and get my dimension. So let's get started. This is recording, right? Yeah. Okay. There's one. Pretty flat. I should be able to measure across those without any problems. And they are certainly thick enough that we're not going to get any real flex. Certainly not with the kind of tool pressure I'm putting on with a pair of calipers. All right. So we have looks like about 7 inches, 950 thousandths. And let me write that down so I don't forget. Okay, I probably can't read my writing. So the swing arm is 8 inches, 220 thousandths. The frame is 7 inches, 950 thousandths. So we need to take off 270 thousandths. Right? Yeah, 270. So we divide that in two. That is 135 thousandths on each side. So about 4.5 millimeters. So 4 millimeters would be 120. It's about 4.5-ish millimeters. So what I want to do is we'll start on one side, assuming this works. It may not. And we'll cut. And then if it starts cutting good, we'll measure, and then cut, measure, cut, till we get that half of that 135 off of there. Then we'll turn it around and do this side. And if all that worked, then we'll do our counter bore. So this has to go in here. All right. And drilling through this bolt made the drill, even though it was dead center, it made the drill walk a little bit. So it only fits one way. It's not very far off. All right, I got a new dowel pin. And I actually got a little electrical tape to put around this in case it wants to fall out. It probably won't, but anyway, if I got this the right direction, maybe I don't. Okay, so that goes in there. Well, it should. It did earlier. There we go. So that goes there. And our pilot goes in from here. Actually, that doesn't work that way. I gotta put the dowel pin in after the bolt. Okay, there's that. We'll use this to hold it while I snug it up. Okay. Got to be pretty snug to get the dowel pin in because I torqued it down pretty good when they drilled it. So the flats on here are just about a 1/2 millimeter, maybe less than that, maybe 1/4 millimeter, 10/1000 short, so that this pulls it all together. It looks pretty close, maybe just a hair less. Looks like it'll go in. Kind of got to fuss with this just a hair until I get it all lined up, which is easy when it's in the vise. Okay, grab some pliers to hold this thing with so I can get it adjusted. Got to line up the notch in the screw with my dowel pin. Finally got this all bolted together. The dowel pin with the notch in the screw seemed like a good idea, but it's kind of a pain to assemble. Anyway, the nice thing is that this is going to run nice and square on here. I did take a diamond lap to these. They are pretty sharp, so I'm hoping put some cutting oil on here and more as we need it, of course. Some on our shafts. Okay, so let me get I got a 1/2-inch corded Milwaukee drill that has enough torque to about pull itself out of your arms, and it runs nice and slow in reverse, so hopefully it will have enough torque. My worry is I can't get enough pressure on this, but we'll find out. Alright, so here we go. It's running in the right direction. It does run out a little bit because this thing is really not very accurate that way, but well, it's cutting. pretty decent surface. It's got a few chatter marks on it, but not too bad. So, you know, I just did something stupid. I don't want to have to unclamp all this again. I should have measured this afterwards and I could know how much to take off. I don't know how much I've taken off. Definitely got some shavings. Okay. Alright, now we got our bars back on here. I can figure out how much I've taken off. I haven't taken off much, about 5 thousandths. Alright, this is yeah, 7 inches, 955. So I've taken off 5 thousandths. So now hopefully I can get a decent measurement on here. Okay, so our finished dimension should be 1.688, assuming I can get there. You can see the rust and gugh that was in the frame. So we'll clean our pilot back up, put them all back in here again, and this time not going to take it out till it's done, or it just don't work. One of the two. Hopefully it'll work. The hardest part is I gotta pull on the frame so I can get enough, and I'm putting my hip against the drill, try to get enough tool pressure. Cutting. It's actually leaving a little lip on the inside where the spot face is just a tiny bit too small, because this is 5/8 and this is 16, but that's easy to deburr. That's just a burr basically. I had to go get the burring tool to get that back in. Okay. So we have taken some metal off, about 30 thou maybe. We'll put a little cutting oil on there and press on. This would be easy in the machine, but don't have much tool pressure out here. Not too bad though. More cutting oil. Getting some decent chips off of there. Drill's getting hot though. It ain't happy about running that slow. Not with that kind of torque. I don't have anything. It's got a gear reduction to go slower. You know, my cordless, but I don't think it has a torque. Well, we could try it. Alright, we're going to try this with my, this is a Milwaukee M18. I've had it for, well, I don't know, 7 or 8 years, and I've used it a lot. It's actually been really good. I can't complain too much, but rather killed this than the corded one because it's older. Let's see, I've got it in reverse, low gear. It's working. Let me find a way to get some more pressure on it. Poor drill. It's not happy about this. It's really not happy about this. Okay, you ready?
Yeah.
Just a tiny bit to take off on this side. Then I got to turn everything around, but I'm going to let this cool down for a while so I don't totally kill it. So I don't really want to have to buy a new one. Okay, this won't be much. Shouldn't be. $686, perfect. Because we needed 688 and maybe a little less. So that is just, this side is just perfect. I'll have to do the other side, but I gotta let everything cool down first. It's not happy right now. Plus I gotta take all this apart and put it on the other side. Okay, camera on? Yeah. So I know this is hard to see. Light sucks in here. You might be able to see in here machine surface. So it's been done on both sides. And if the measurements are right, we should have, I have not tried this, about 10 thousandths clearance. This should fit in there with about 10 thousandths to spare. If not, then I'll have to take a little more out. Look at that. Whoops. Come on. Looks like it's going to go. Let's try it now. Well, I gotta remeasure with the blocks. I think we are real close. So I took this one down to 1 inch, 800, or 1 inch 680. This was about 1 inch 685, so of course there's a lot of room for error in there. Alright, I got 8 inches, about 175 thousandths. What did I say that was? 8 inches, 220. So, yep. Well, hell. I blew it somewhere. And I got, that side looks smaller than this. Maybe I didn't measure right on this side. So, yeah, I got about 1 inch, or 8 inches, 175. I need 220. So I need about 45 thousandths to go. This side's only 5 thousandths higher. So I need to take about another 25 off of there and about another 20 off of here. My drill is it's not Doesn't smell bad, but it definitely needs to cool off. So this may not get done today. So we're gonna shut the camera off and probably come back tomorrow. Let the drill cool off and it's time for dinner. And battery still got a little bit. Maybe later, we'll see. After dinner perhaps. Alright, so we're back. Had to let the drill cool off. Get a little pizza. So I had to take another 25 off of each side or so. At least that's what I think. The measurements are telling me. I think I measured the swing arm wrong the first time. So we're going to find out if it fits. I have not tried this yet. You'll have to trust me on this, but I haven't. It should. Oh yes. Yeah. All right, that looks like it fits. Now, where's the axle? Not axle, spindle, pivot, which I know is too short, but I just want to see that it goes. Oh, that ain't gonna work because that's 17 millimeters. I haven't made the holes bigger yet. Well, that won't work. We'll stick this in there just to see it go up and down. Looky there. Beautiful. Obviously we're not going to need that much travel. And there is, back this out. So there's quite a bit more work to do still to adopt this. These braces will interfere with the shock absorber right here. So I'm going to have to make new ones that are going to come out and come back in. That's no problem. And then of course we've got to make mounts up here for the shock and down below for the bottom half of the shock linkage. And but yeah, I think this is going to be pretty sweet. Of course, the chain, the sprocket to pivot distance is a lot more than on the original dirt bike that this came off of. So probably have to limit the travel to some degree, and I'll definitely have to put some kind of a chain guide or chain tensioner on it. But that's about it. Part 2 will be line boring the pivot bosses. I'm going to take them out 1 millimeter to 17, and they're at 16 right now. And I did think of a way, I believe, to make it easy to reset the cutter depth. So I'm going to have to make a little bushing for it and a shim, but I think that'll work, and then I can do it a lot easier. So anyway, that's about it for today. Hopefully this shows up okay. I think this is probably a unique project. Maybe somebody else has done this way, and if they have, that'd be awesome. I'd love to hear about it, but if not, then this is maybe unique. There's other things that got to be done. There'll need to be a spacer made to go in between these. This, on the original bike, the engine casing goes in here. So obviously that is not the case on this bike. So I'll just turn a piece of aluminum, bore it 17 millimeters, make it fit in there, no problem. That's one of the easy things, right? That's all. Have a great day. Thanks for watching, and take care of yourselves.